A laser pointer or laser pen is a small handheld device with a power source and a laser diode emitting a very narrow coherent low-powered laser beam, a visible light, intended to be used to highlight something of interest by illuminating it with a small bright spot of colored light. Power is restricted in most jurisdictions, not to exceed 5 milliwatts. The small width of the beam and low power of typical laser pointers make the beam itself invisible in a reasonably clean atmosphere, only showing a point of light when striking an opaque surface. Some higher-powered laser pointers project a visible beam via scattering from dust particles or water droplets along the beam path. Higher power and higher frequency green or blue lasers may produce a beam visible even in clean air because of Rayleigh scattering from air molecules, especially when viewed in moderately to dimly lit conditions. The intensity of such scattering increases when these beams are viewed from angles near the beam axis. Such pointers, particularly in the green light output range, are used as astronomical object pointers for teaching purposes. The lowest availability of infrared diode laser modules of up to 1000 milliwatts output has created a generation of IR-pumped frequency doubled called diode-pumped solid-state laser pointers in green, blue, and violet, of higher visible power, typically up to 300 milliwatts. Because the IR laser component in the beams of these visible lasers is difficult to filter out, and also because filtering it contributes extra heat which is difficult to dissipate in a small pocket laser pointer package, it is often left as a beam component in cheap high-power pointers. This invisible laser light component causes a degree of extra potential hazard in these devices when pointed at nearby objects and people. Laser pointers make a potent signaling tool, even in daylight, and are able to produce a bright signal for potential search and rescue vehicles using an inexpensive, small and lightweight device of the type that could be routinely carried in an emergency kit. If aimed at a person's eyes, laser pointers can cause temporary disturbances to vision. There is some evidence of rare minor permanent harm, but low-powered laser pointers are not seriously hazardous to health. They may be a major annoyance in some circumstances. A dot of light from a red laser pointer may be thought to be due to a laser gun sight. When pointed at aircraft at night, laser pointers may dazzle and distract pilots, and increasingly strict laws have been passed to ban this. Colors and wavelengths. Early laser pointers were helium neon gas lasers and generated laser radiation at 633 nanometer, usually designed to produce a laser beam with an output power under 1 milliwatt. The least expensive laser pointers use a deep red laser diode near the 650 nanometers wavelength. Slightly more expensive ones use a red-orange 635 nanometers diode, more easily visible because of the greater sensitivity of the human eye at 635 nanometers. Other colors are possible too, with the 532 nanometers green laser being the most common alternative. Yellow-orange laser pointers, at 593.5 nanometers, later became available. In September 2005, handheld blue laser pointers at 473 nanometers became available. In early 2010, Blu-ray laser pointers at 405 nanometers went on sale. The apparent brightness of a spot from a laser beam depends on the optical power of the laser, the reflectivity of the surface, and the chromatic response of the human eye. For the same optical power, green laser light will seem brighter than other colors because the human eye is most sensitive at low light levels in the green region of the spectrum. Sensitivity decreases for redder or blue wavelengths. The output power of a laser pointer is usually stated in milliwatts. In the U.S., lasers are classified by the American National Standards Institute and Food and Drug Administration. Visible laser pointers operating at less than 1 milliwatt power are Class 2 or 2. and visible laser pointers operating with 1 to 5 mW power are Class 3A or E. Class 3B or IIB lasers generate between 5 and 500 mW. Class 4 or IV lasers generate more than 500 mW. The US FDA Code of Federal Regulations stipulates that demonstration laser products, such as pointers, must comply with applicable requirements for Class 1, EA, 2, or EA devices. Red and red-orange. These are the simplest pointers, as laser diodes are available in these wavelengths. The pointer is nothing more than a battery-powered laser diode. The first red laser pointers released in the early 1980s were large, unwieldy devices that sold for hundreds of dollars. Today, they are much smaller and generally cost very little. In the 21st century, diode-pumped solid-state red laser pointers emitting at 671 nanometers became available. Although this wavelength can be obtained directly with an inexpensive laser diode, higher beam quality and narrower spectral bandwidth are achieved through DPSS versions. Yellow laser pointers emitting at 593.5 nanometers became available in the last few years. Although they are based on the DPSS process, in this case two lasing lines of the ND-YV04, 1064 nanometers and 1342 nanometers, are summed together with a nonlinear crystal. The complexity of this process makes these laser pointers inherently unstable and inefficient, with their outputs ranging from 1 mW to about 10 mW, greatly varying with temperature and usually mode hopping if they get too hot or too cold. That is because such a complex process may require temperature stabilizers and active cooling, which can't be mounted into a small-sized host. Also, most smaller 593.5 nanometers pointers work in pulsed mode, so they can use smaller and less powerful pumping diodes. New 589 nanometers yellow laser pointers have been introduced using a more robust and secretive method of harmonic generation from a DPSS laser system. This sodium wavelength, although only 4.5 nanometers away from the older 593.5 nanometers, appears more gold in color compared to the more umber appearance of the 593.5 nanometers wavelength. Astronomical observatories use a specially tuned dye laser at 589.2 nanometers to create a laser guide star for use with astronomical adaptive optics. Green laser pointers appeared on the market circa 2000, and are the most common type of DPSS lasers. They are more complicated than standard red laser pointers, because laser diodes are not commonly available in this wavelength range. The green light is generated in an indirect process, beginning with a high-power infrared Algaz laser diode operating at 808 nanometers. The 808 nanometers light pumps a crystal of neodymium-doped yttrium orthovanadate, which lasers deeper in the infrared at 1064 nanometers. This lasing action is due to an electronic transition in the fluorescent neodymium ion Nd, which is present in all of these crystals. The ND-YV04 or other Nd-doped crystal is coated on the diode side with a dielectric mirror that reflects at 808 nanometers and transmits at 1064 nanometers. The crystal is mounted on a copper block, acting as a heat sink. Its 1064 nanometers output is fed into a crystal of potassium titanyl phosphate, mounted on a heat sink in the laser cavity resonator. The orientation of the crystals must be matched, as they are both anisotropic and the ND-YV04 outputs polarized light. This unit acts as a frequency doubler, and halves the wavelength to the desired 532 nanometers. The resonant cavity is terminated by a dielectric mirror that reflects at 1064 nanometers and transmits at 532 nanometers. An infrared filter behind the mirror removes IR radiation from the output beam, and the assembly ends in a collimator lens. ND-YV04 is replacing other ND-doped materials such as ND-YAG and ND-YLF in such systems because of lower dependency on the exact parameters of the pump diode, wider absorption band, lower lasing threshold, higher slope efficiency, linear polarization of output light, and single-mode output. For frequency doubling of higher power lasers, LBO is used instead of KTP. New lasers use a composite ND-YV04 KTP crystal instead of two discrete ones. Some green lasers operate in pulse or quasi-continuous wave mode, to reduce cooling problems and prolong battery life. An announcement in 2009 of a direct green laser promises much higher efficiencies and could foster the development of new color video projectors. In 2012, Nichia and Osram developed and manufactured merchant high-power green laser diodes which can emit green laser directly. Because even a low-powered green laser is visible at night through Rayleigh scattering from air molecules. This type of pointer is used by astronomers to easily point out stars and constellations. Green laser pointers can come in a variety of different output powers. The 5 mW green laser pointers are the safest to use, and anything more powerful is usually not necessary for pointing purposes since the beam is still visible in dark lighting conditions. The United States Coast Guard requires their air crews to return to base if a green laser is pointed at them, and have their eyes examined for eye damage. People have been given up to 5 years in jail for aiming a green laser at an aircraft. Blue laser pointers in specific wavelengths such as 473 nanometers usually have the same basic construction as DPSS green lasers. In 2006, many factories began production of blue laser modules for mass storage devices, and these were used in laser pointers too. These were DPSS-type frequency double devices. They most commonly emit a beam at 473 nanometers, which is produced by frequency doubling of 946 nanometers laser radiation from a diode-pumped ND-YAG or ND-YV04 crystal. For high output power, BBO crystals are used as frequency doublers. For lower powers, KTP is used. The Japanese company Nichia controlled 80% of the blue laser diode market in 2006. Some vendors are now selling collimator diode blue laser pointers with measured powers exceeding 1,500 milliwatts. However, since the claimed power of laser pointer products also includes the IR power still present in the beam, comparisons on the basis of strictly visual blue component from DPSS-type lasers remain problematic, and the information is often not available, because of the higher neodymium harmonic used, and the lower efficiency of frequency doubling conversion. The fraction of IR power converted to 473 nanometers blue laser light in optimally configured DPSS modules is typically 10 to 13%. About half that typical for green lasers. Blue lasers can also be fabricated directly with InGaN semiconductors, which produce blue light without frequency doubling. 450 nanometers blue laser diodes are currently available on the open market. Some blue diodes are capable of very high power, such as Nichia's NDB7K75 diode, which can continuously output over 5 watts of energy if overdriven. The devices are brighter for the same power than 405 nanometers violet laser diodes, since the longer wavelength is closer to the peak sensitivity of the human eye. Mass production of laser diodes for commercial devices like laser projectors have driven down prices. Recent popularity of the high-power version of these 447 nanometers pointers, which also have improved optics for better collimation and lower divergence, rivals the hazards associated with the use of these portable devices by persons of questionable intention, and cost has diminished to be competitive with DPSS green lasers wavelengths. Violet lasers emitting a violet light beam at 405 nanometers may be constructed with GaN semiconductors. This is close to ultraviolet, bordering on the very extreme of human vision, and can cause bright blue fluorescence, and thus a blue rather than violet spot, on many white surfaces, including white clothing, white paper, and projection screens. Due to the widespread use of optical brighteners in the manufacture of products intended to appear brilliantly white, on ordinary non-fluorescent materials, and also on fog or dust, the color appears as a shade of deep violet that cannot be reproduced on monitors and print. A GaN laser emits 405 nanometers directly without a frequency doubler, eliminating the possibility of accidental dangerous infrared emission. These laser diodes are mass-produced for the reading and writing of data in Blu-ray drives. As of September 2011, update, 405 nanometers blue-violet laser diode modules with an optical power of 250 milliwatts. Based on GaN violet laser diodes made for Blu-ray disc readers, had reached the market from Chinese sources for prices of about $60 including delivery. At the same time, a few higher-powered 404 to 405 nanometers violet laser pointers have become available which are not based on GaN, but use DPSS frequency doubler technology from 1 watt 808 nanometers Gala's infrared diode lasers. As with infrared-driven green laser pointers above, such devices are able to pop balloons and light matches. But this is as a result of an unfiltered high-power infrared component in the beam. Applications. Pointing laser pointers are often used in educational and business presentations and visual demonstrations as an eye-catching pointing device. Red laser pointers can be used in almost any indoor or low-light situation where pointing out details by hand may be inconvenient, such as in construction work or interior decorating. Green laser pointers can be used for similar purposes as well as outdoors in daylight or for longer distances. Laser pointers are used in a wide range of applications. Green laser pointers can also be used for amateur astronomy. On a moonless night, a green laser pointer beam can often be clearly seen, allowing someone to accurately point out individual stars to others nearby. Also, these green laser pointers are commonly used by astronomers worldwide at star parties or for conducting lectures in astronomy. Astronomy laser pointers are also commonly mounted on telescopes in order to align the telescope to a specific star or location. Laser alignment is much easier than aligning through using the eyepiece. Industrial and research use laser pointers are used in industry. For instance, construction companies may use high-quality laser pointers to enhance the accuracy of showing specific distances. While working on large-scale projects, they prove to be useful in this type of business because of their accuracy, which made them significant time savers. What is essentially a laser pointer may be built into an infrared thermometer to identify where it is pointing, or be part of a laser level or other apparatus. They may also be helpful in scientific research in fields such as photonics, chemistry, physics, and medicine. Laser pointers are used in robotics, for example, for laser guidance to direct the robot to a goal position by means of a laser beam, i.e., showing goal positions to the robot optically instead of communicating them numerically. Leisure and entertainment. Entertainment is one of the other applications that have been found for lasers. The most common use of lasers in entertainment can be seen in special effects used in laser shows. Clubs, parties and outdoor concerts all use high-power lasers, with safety precautions, as a spectacle. Laser shows are often extravagant, using lenses, mirrors and smoke. Lasers have also become a popular plaything for pets and other animals, namely cats and dogs, whose natural prey drive is triggered by the moving laser and will chase it or try to catch it as much as possible, but obviously never succeed. As a result, laser pointers have become a popular form of entertainment for many pet owners. However, laser pointers have few applications beyond actual pointing in the wider entertainment industry, and many venues ban entry to those in possession of pointers as a potential hazard. Very occasionally laser gloves, which are sometimes mistaken for pointers, are seen being worn by professional dancers on stage at shows. Unlike pointers, these usually produce low-power, highly divergent beams to ensure eye safety. Laser pointers have been used as props by magicians during magic shows. As an example of the potential dangers of laser pointers brought in by audience members, at the Tomorrowland Festival in Belgium in 2009, laser pointers brought in by members of the audience of 200 milliwatts or greater were found to be the cause of eye damage suffered by several other members of the audience, according to reports about the incident filed on the ILDA website. The report says that the incident was investigated by several independent authorities, including the Belgian police, and that those authorities concluded that pointers brought in by the audience were the cause of the injuries. Laser pointers can be used in hiking or outdoor activities. Higher-powered laser pointers are bright enough to scare away large wild animals, which makes them useful for hiking and camping. In these circumstances, a laser pointer can also serve as a handy survival tool, as it can be used as a rescue signal in emergencies, which is visible to aircraft and other parties, during both day and night conditions, at extreme distances. For example, during the night in August 2010, 2 men and a boy were rescued from marshland after their red laser pen was spotted by rescue teams. Weapons systems accurately aligned laser pointers are used as laser gun sights to aim a firearm. Some militaries use lasers to mark targets at night for aircraft. This is done to ensure that friendly and enemy targets are not mistaken. A friendly target may wear an IR emitting device that is only visible to those utilizing night vision to pinpoint the exact location of an enemy combatant. They would simply illuminate the target with a laser beam detectable by the attacking aircraft. This can be one of the most accurate ways of marking targets.